My name is Ghida. I'm VP of Data and Product at Sector Alarm. So for the Swedish among you, you might know Sector Alarm because it's present in Sweden. I'm just back from our office in Gothenburg. It's one of the leading safety providers in Europe. And we'll talk a bit more about the business. And before being at Sector Alarm, which is now for 1.5 years, I was at Meta for more than 5 years, working as a tech lead and quantitative engineer focusing on infrastructure optimization. So why this talk towards a business-driven data architecture? I know it's a bit of a cheesy talk. You don't know what you're signing up for. It's not technical. It's not business. And the reality is that it is really in between both. And why I thought about this talk and submitted it, because I feel I've been on both sides of the story. So initially, I was a data scientist. And then at Meta, I was in a role where I was between data scientist, data engineer, systems engineer. So really a technical person. And then at Sector Alarm, I joined initially as a chief architect, and then I was asked to lead the data team, which was newly formed, and then to lead product. So I found myself at both ends of the spectrum as a leader of an org who has to speak to the business and understand the business needs and convince the business that this investment in data infrastructure and data teams are actually worth it and are going to drive the business forward. And I've also been an engineer implementing and building and doing analytics and all of this. And I didn't necessarily at that point understand the value add of my work for the business. So this is why I thought it's important to bridge the gap between the technical side, the data architecture, the data infrastructure, the analytics that we decide to do on top of our data, the AI use cases, all of this, and the business value. And this talk is really about this. Should use this. Okay, so to do this, and when actually I was asked to design a target data architecture and put together the team to build it, I had many questions around where to start from. And I spent a lot of time thinking, okay, where should I start? And I came up with this framework, which I think is kind of working. So that's why I wanted to share it with you. So I will be going in this talk through this framework and through the different steps. But the steps here really are first starting by understanding the business. What does your business do? How do you make money? How do you spend money as a business? What are the main priorities for your business leaders, for your C-suite for the coming 5 to 10 years? So this is the first thing you should be starting with, even as a technical person. The second step would be to map the business objectives to data products or data initiative. So what is a data product really? It could be anything. It could be a system, it could be a tool, it could be a dashboard, it could be a feature in your product. As long as it has data at its core, then you can call it a data product. It could be a chatbot, it could be a dashboard in Power BI, it could be a recommendation engine baked into your e-commerce website. Whatever it is, if it requires a lot of data to function, then it's a data product. Then, once you have done that, mapping the business objectives into data products, you need to start thinking about the flows. So you have an idea about what the data product should be like. Like, is it a visualization? Is it a chatbot? Is it a recommendation engine? Whatever. For it to work, what does it take? What kind of data does it need to ingest? What kind of transformation does it need to apply to this data? What kind of analytics should be done on top? And then what is the outcome? And in which system should this outcome live? So this is what the data flows that we're going to give examples about and touch upon later in this presentation are all about. And then once you have done all of this, you need to take all this information, because it's quite a bit of information. You need to digest it, and you need to zoom out and consolidate and think, what are the data architecture elements that could actually address many of these use cases, or ideally all of these use cases and data flow? What would be, for instance, a data store that could allow me to store all kinds of data that I'm thinking about for all these use cases? What would be an analytics framework that would also allow me to do many of these analytics required for these different use cases, etc.? What would be also a framework that might have out of the box the visualization tools that I need. So you really need to think in terms of consolidating the tools that you need to use across these different data flows. So throughout this talk, we'll go one by one through each of these steps, and to make it a bit more real, because otherwise I'll keep speaking and you won't really understand what exactly am I talking about. I'll give specific examples, and I'll give examples from my current experience and from Sector Alarm, not really to market the company or anything like that, but more to be more concrete and more real in my approach, and to allow you to take this and apply it to your own companies. Okay. So starting by the business, understanding the business and the business objectives. Okay, so how does my company make money? The company that I work for, Sector Alarm, we sell smart alarm systems and related services to homeowners and small businesses. And in return, we sometimes take a small upfront and a recurring monthly subscription. So that's mainly what the business is providing. And whatever company you work for, you really need to be able to articulate this quite easily in a sentence. That's quite important to start. Second point here is that how does my company make money? And in the case of my company and home safety companies in general and smart home companies, how does the company make money? So basically by selling, by selling a service and a system and having a recurring monthly subscription. So the recurring monthly subscription is really the main source of revenue, one would say. Now, how does the company spend money? There are obviously lots of costs. These costs include marketing, like targeting online the right customers, etc. Field sales, so going door to door, trying to sell these systems and services. Installations, once we have a customer, we want to go and install the system. 24/7 alarm monitoring service, because this is a lot like of the value add of the service really is the 24/7 and the response time. So this is quite important and it's part of the offer, but it's also part of the cost structure. And finally, customer support. And customer support means that you have people, agents, 24/7 available to reply to calls, but you need to also evolve and maybe you want to have different ways to do that, for instance, through chatbot, etc. And we will see that. But customer support also means that you might need to invest in sending engineers to the field in some cases when the customer is having issues with their system, etc. Or you need to find other automated ways to do so. But all of this is spending money. And then what is the business focusing on in the next 5 to 10 years? So for Sector Alarm, we have what we call mature markets. So these are mainly the markets in the Nordics, like Norway, like Sweden, like Finland, etc. And we have like new markets in France and Spain and Italy, etc. The focus of the company is to keep or grow steadily, but mainly reduce churn in the mature market. So keeping the retention, hopefully increasing a bit the base, but really the focus here is keeping the base, keeping it satisfied, reducing the churn. Now in the new markets, there is a different strategy. Then in the new markets, the focus is on accelerating growth. So we really need to grow fast because we don't have a lot of customers. Now on the cost side, of course, the focus is on reducing the customer acquisition costs. And these include all the things, or many of the things that I have mentioned, like marketing, field sales, system installation, etc. Also the hardware cost, obviously. And then reducing the recurrent monthly costs. So a lot of things also go into this, but some of them mainly are paying for the agents and also the systems and the infrastructure for monitoring alarms 24/7, paying for customer service, for engineers, for all of this. So this is part of the monthly cost. So now that we have covered what is this business about and how does this business make money and spend money, the second step would be to map the objectives of the business into data products. So for instance, if we start by churn prevention, how can we do that? One way to do that is to predict a customer propensity or likelihood to churn based on a number of data points that we have about them. Could be data points about them, their property. It could be about their experience. For instance, do they have a lot of false alarms? Do they use their system that often? We have an app. Do they use the app that often or not? Do they leave us any feedback? Do they often call customer service, etc.? So there are a lot of data points that we can actually be collecting to have an idea or predict the churn propensity of a given customer. And the way we kind of decide on which data we need to collect is a mix of really seeing what we have and collecting this and putting it together and aggregating it and building what we call the customer master data. And it could be also through talking to stakeholders. So often your stakeholders have really good hypotheses about what could be driving churn from their experience. And your role is really translate these hypotheses into data that you're collecting and that you're validating through your churn model. And then once you have collected this data, of course, you need to do feature engineering, you need to do model development, so you can build a machine learning model. It could be as simple as a regression, but it could be as complicated as a neural network. You need to continue building it till you find something that is accurate enough or precise enough, or whatever is a key success metric for you regarding the value add of this model or the performance of this model. So now, great, you have collected whatever data you could collect about the customer. You have built a churn model. You're able to predict different customers' likelihood to churn. Great. Still, the business has zero value add from all this amazing process and maybe, like the amazing, very complicated neural network was 5 layers that you built. I mean, good for you, but the business value add is not there yet. So how do we use it? So there are 2 ways to use it, or at least these are the 2 ways that we agreed on after talking with the business and doing the brainstorming. One is to use these scores along with the weights of different features or variables in the model, which gives us like what is the driver for churn, for instance. Use them for proactive intervention. So if I know that a customer in my base is likely to churn or has a high likelihood to churn, and this is driven, for instance, by the fact that they have a lot of false alarms, I should be, as a company, able to proactively intervene and to customize my intervention based on my knowledge of this driver. So proactive intervention is one way, can be done by customer service teams, can be done by marketing team. So really you need to give this data to these teams and enable them to use it. Explain it to them, enable them to use it, enable them to automate outreach or personalize outreach based on what this data is telling them really. Now the other way to do this, is reactive intervention. Because you cannot call all of your customers, but the customers sometimes, and more often than not really, when they are unhappy, they will call you. So when they call you, you better know what they are gonna complain about. And you better know where they are in their journey with you. Are they really pissed off or are they happy? So using this data and really putting it at the service of customer service agents when the customer calls and showing them, hey, this incoming call is from a customer that has a 90% likelihood to churn. And guess what? It's driven by a high price or something like that, is very important for the customer service agent to know. And you can add a layer on top of this, which is recommending an action based on that. Give them a discount or do something else. Send like an engineer service visit or do something else. It could be anything, but really it should be also customized. So enabling customer service agent to use this information, the outcome of this model, to react in the right way to calls and inquiries from customer is also very important and is what is going to drive the business value. And how do we monitor this? We'll touch this on this later, but really you should see a drop on your churn, in your churn. And at the same time, this drop in your churn should be intelligent, should be smart. It should not be that, well, we prevented a lot of people from churning, but actually we decline or we decrease our revenue by 50% because we gave everyone 50% discount. This is not the smartest way to do it, and this doesn't work for a business, and it's definitely not sustainable. So both the churn level and how much it impacted your ARPU as a company and your performance as a company are key KPIs that you should be looking at. And these KPIs also, you need to build the data product for them. You need to build visualization and dashboards to monitor them. And you decide on them and you build this product with your business stakeholders. So this is the churn use case. Now, if we think about acquiring more customers, so the growth story that I just mentioned, but at a lower cost, so lowering the customer acquisition cost, what can we do there? Lots of things can be done there. And this is, by the way, a non-exhaustive list. I'm sure if I think more, if you get think more about your particular companies and context, you will come up with a lot of ideas. So some ideas here that I would like to share with you is customer portfolio analysis. We know our existing customers. We know many things about them, where they live, how big are their houses, what is their median age, etc. And of course, we need to protect this data, but we can analyze it and aggregate to have an idea about who are our customers, to create what we call in marketing customer personas. And once you have this understanding of customer personas, you can actually use it to target the people who are likely to use your service and to enable this better targeting for them. So instead of reaching out to everyone, you can reach out to this segment of people or of businesses that are more likely to need and to purchase your services. So this is one use case. The other use case is what we call proactive lead scoring. So a lead is someone who is kind of interested in your service, but they're not yet a customer. They didn't sign a contract. They didn't, have a system installed, nothing like that. But they're interested. They have some interest. So what do you want to do here? You really want to score your leads to see which ones are more important than others, or which one are more likely to convert than others. Why? Because you really want to send your best agents to these people. And you need to be smart about that. So proactive lead scoring is possible, and you can build machine learning model. You can use the previous or the historical data you have about leads and which ones of these leads turned into customer to do this kind of prediction and feed it actually into, for instance, how your agents work and how your sales team work and who they reach out to. Third thing is agent performance optimization. So the way we sell products, there are two channels. One is the agent channel. So this is basically an agent calling a customer and trying to sell the service to them on the phone. The other way is the field sales team. So people going, knocking on doors, showing the product in real time, all the system, etc. And we need to optimize both. So agent performance optimization, basically if you record the calls the agent are having with your customer, you do some analysis on top of this call about the performance, about which calls worked, which calls didn't work. And you use this to train your agent and also to make sure that you're directing the leads to the right agent. So for instance, if an agent has a better scoring, you might want to direct your lead with a high likelihood of converting to them. So you need to do the transcripts of this call and to run, for instance, large language models on top of them to see what is the performance there and to rank this performance and to use it for different purposes. So this is also one way to lower your acquisition costs and to improve the conversion rate. The fourth thing is field sales representative enablement. So these are like sales personnel on the field going knocking on doors. Sometimes they are new. There is a high turnover in this kind of jobs because usually you have, for instance, college students doing it part-time, etc. So, and also it's based on commission. So there is not really a fixed salary. So you have a turnover. So how do you make sure that these sales personnel are educated, are up to date, are trained well? Maybe you can empower them through a chatbot that can answer their questions, and therefore they can provide more accurate information and more personalized information for the potential customer. So all of these are initiatives. All of these are, ideas that can easily translate into data products and that can really translate into lowering your customer acquisition costs and acquiring more customers on the long run. Now on reducing the recurring monthly costs. So this is the cost you incur as a company once you have the customer. So you secure the customer and you're just running your operations. This is what you pay every month. So for a company like Sector Alarm and for any company in the home security space or smart home space, etc., it could involve any of the following or others as well. Improving alarm handling. For instance, you really want to reduce the amount of false alarms you get, because every false alarm is most likely someone picking a phone and calling the customer. So you want to reduce the amount of false alarms. You want to auto-handle the you want to auto-handle the repeated false alarms. So if you know that a given system is giving you a lot of false alarms, and every time you get an alarm but it's false, maybe you want to automate the way you handle this alarm and not send it to a person because it's taking some of their time. So this is one way to actually reduce your recurring monthly costs. Another way is, instead of having customer service agents, you can also have chatbots within the app that the customer can talk to. And these chatbots can be really good and can answer most of the questions. And for the ones that they cannot answer, they can be directed to a customer service agent. And finally, you can optimize the field service, so the work of the installers, the engineers, etc., by using predictive maintenance. So once you know that something is going to go wrong with this customer, with their system in advance, and you're able to predict it, maybe you can reach out to them in advance. Maybe you can do things that don't involve sending engineer, because this is quite expensive. Or maybe you can do bulk actions. So if I know that a number of my customers in this neighborhood are likely to have issues, instead of sending an engineer at different time slots, different days, weeks to each of them, I can bundle this mission and send an engineer to all of them at the same time and do some optimization there. And that's okay, because I'm being proactive in this. So I have enough of time to plan this and I'm not reactive. So these are ways as well where you can really use or build data products or initiatives that can really have an impact on your recurring monthly cost at the company. And of course, you want to monitor all of this. So you have these initiatives, you have this idea about reducing churn, you have this idea about your customer chatbot, you have this idea about, for instance, transcribing the calls of your agents and scoring these calls and using it to training them and all of this. You really need, once you build this initiative, you really need to monitor how they are performing, and to do that, you need to be looking at some KPIs and monitor the evolution of these KPIs over time. For instance, if we want to really monitor if our customer acquisition cost is decreasing, we can actually look at the lead conversion rate. Is it improving? Are more of the people that are interested in our services becoming actual customer? And can this be attributed to some of the initiatives that we've implemented, such as agent optimization or empowering the field service, etc.? Same thing for retention. Is our churn rate actually decreasing while still not hurting the business too much? Same for operational efficiency. Are we seeing a reduction in the number of customer service and alarm monitoring agents while the customer satisfaction is still the same? So you really, for each of these initiatives, once you launch it, you really need to define key success metrics and monitor them over time and give your business stakeholders the tools, the dashboards to do so. Okay. So now we understood the business. We translated the business objectives into data products or data initiatives. Now we really need to think a bit deeper. So I have an idea about what this initiative is about, but how would it really work? How would the data flow? So, of course, I listed here so many ideas. We cannot go through the flows of each of these ideas, but I selected some of these ideas for you to show you how we think about it. For instance, if we think about churn modeling as a use case. So at the end, what do you want? You really want to provide a view to your customer service agents about which customers are most likely to churn. This could be one thing, okay? So to do so, this information where should it live? It should live in a system like the CRM, because the CRM is a system that is usually used in most companies by a customer service department, okay? But how do you get it there? So to get it there, you need to train a model. This model will need to take data from many of your systems. These are just like some of the systems on the left that your customer master data would need to pull data from. So you pull data into your customer master, you do feature engineering, you build a machine learning model. This model predicts the customer churn propensity, shows you the churn driver. You can put this in like a Power BI dashboard or Tableau kind of dashboard or any kind of visualization that can be used by your customer service agents. Or you can actually feed it directly back into your CRM and show it to them there. So here the end product really is a dashboard or a view in your CRM, but the journey is quite more complex than that. Because to get there, you need to pull data from different systems, you need to build your machine learning model, and you need to inject the output in these systems, and you need to update it. So this is an example of a flow. Another flow, I think I copy-pasted some slides from one presentation to another, and the flows are not as nice as they should have been, but it's okay. You can follow what I'm saying to understand. Okay, 24/7 customer chatbot as a use case. How would this flow, for instance, work? What you see as a customer, okay, I have an app that I can use to control my system, to, for instance, arm, disarm, activate smart plugs, whatever it is. But I can also use it to speak to. I have a chatbot there, so I can use it for assistance, basically. So I have an incoming customer query. So this is what you see, like the chatbot, and the ability, giving the customer the ability to write a query in text format in any language, in any dialect, in the chatbot in the app. But how is it really working behind the scenes? So what is really working is that we're taking this query, we're translating it to English, to like plain English. And then after that, we're using RAG. RAG means Retrieval Augmented Generation, enabled LLM. So we're using one of the existing LLM model, but instead of just making this LLM run as is using the available data on the internet, we're making it use our internal data. So what kind of data? Could be customer data, could be also generic data about how an alarm system, for instance, works, or how you can configure it, etc., what we call knowledge base. So just to give you an example, let's say as a customer, I go and write something like, my system is running out of battery and I'm getting beeps, okay? What the chatbot should be doing, here, of course, we're assuming that you're already in the app, so you're already authenticated. We know that you are a customer, okay? So what the chatbot should be doing is like, first, is this, like, what kind of system this person has? Because there are different systems, right? Is it true that some components in the system are out of battery? If yes, which components? Is it the smoke detector? Is it the gateway? Is it the motion detector on the garden door? What is it exactly? So you need to check this, and you need to go to some internal system and look at customer data or panel data related to a customer and the property in this customer master data to check this. If, for instance, you find out that actually the battery is great, you should not answer the question. You should say, like, no, your battery is fine. This, like, something else is wrong. Call us or something like that, or what else is wrong. But if you find out that one of the components or many of the components have issues, then you can actually go to your knowledge base and query how to change a smoke detector that is, I don't know, built by this manufacturer, this version, etc. And this you can find in your knowledge base, which is kind of an internal encyclopedia about how to, configure different components, how to maintain different components, etc. But to do so and to really basically focus your query on this specific component and not all the components that the company is installing or that the customer has, you really need to know which component is actually having issues. So the customer data allows you to know where is the problem. The knowledge base allows you to find the answer to this specific problem. And for a lot of queries, we see that we need this hybrid approach of both generic data available in the knowledge base and customer-specific data. Of course, there are some exceptions. Like, for instance, if I'm asking about, like, when is my next invoice or how much should I be paying on my next invoice, maybe it's information that is just specific to me. So the system needs to go directly into my financial information. But for many of these other use cases, really, like, a lot of this information would be a mix of public or generic information and customer-specific information. And you need to basically prompt your LLM in a way to enable this and to make it understand these different flows that needs to follow for different types of queries. Okay. The third use case is optimize alarm handling as a use case. Yeah, luckily this graph is fine. So let's celebrate this. Okay, so optimize alarm handling as a use case. So how it works, you have like gateways at different people's homes, and these gateways are connected to their components, etc., right? And the alarm event usually get communicated from the gateway into an alarm event hub. Of course, you don't have one alarm event hub, you have many for scalability purposes, but here I'm just simplifying a bit the architecture. So from the gateway, you'll send an event, an alarm event, which includes, among other, the gateway ID and then the event type. Is it like a smoke event? Is it like water leakage event? Is it a motion event? Whatever it is, maybe you have some details about the zone. So you know, for instance, if it is like motion detector that went off, you need to know whether it's, you know, in your living room or in your garden or somewhere else, right? So you might need this information as well as part of the alarm event. And you send this event to the alarm event hub. So the role of this hub is to handle your event and mainly do like something very important, which is decide on how to route it, like how important is your event, and based on this to route it to the right queue. So for instance, anything that is related to smoke-related event will go to a given queue because it's higher priority. Other events might go to a different queue. Some events we know that they are likely to be false. For instance, if I have armed my system and I forgot about it, I'm just going back home, okay? It's very normal that the alarm will go off. We usually send an SMS, but if the customer is able to put their code on the keypad within less than a minute, then we know that this was the case. If not, then we know that, no, this is actually a true alarm, okay? So there are different queues based on the type of event that you are sending. And you really want to make this alarm event hub smarter and smarter. So how do you do so? You can, of course, log the alarm events that you get over time. You can log the response because more often than not, I mean, usually you have the agent in the alarm monitoring center calling the customer and checking if this was a real event or no. Sometimes you have the police involved, all of this. So you actually know if this was a real event or a false event. So you have the outcome as well. So you can put all of this in your alarm logs, data store, data lake, whatever you want to call it. And then you can analyze it later on offline. You can say, okay, like this type of event from this house, from this zone, etc., how likely they are to be false versus true. And once you do that, you can feed this again into your alarm event hub to make it even smarter in the way it's directing the events to different queues. And ideally, what you want to do is to auto-handle the maximum amount of false alarms and to send the alarms that are less likely to be false and that are higher priority to the right people to make sure they are caught on time and that the response time is very fast. So this is also, you know, an important use case. It has an impact on customer satisfaction, but it also has an impact on the cost big time. And it's really important to go through like the end-to-end flow because it allows you to see like the complexity. So here you have real-time data streaming, for instance. Then you have an offline analytics function. Then you have a data store. Then you have all of this. So really drawing these data flows allows you to see the complexity of the architecture. Okay. So finally, you've done all of this. It's a lot of work, and it can take months, actually. It can involve, as you have seen, business stakeholders. It can involve engineers, architects, etc. So you really need to work with a lot of people. But you gathered all this information. You drew these flows for the main initiatives that you want to focus on. You really need now to take a break, take a beer, zoom out, and decide on a consolidated tech data stack that enables your data flows. Okay, so you really need to see what is the common denominator between all these things. What would be maybe a framework, a tool that allow you to have all these functionalities that you need, whether in terms of type of data that you want to store, whether it is in terms of visualization tools and how they are supported out of the box, whether it is in terms of having a suite of analytics tools that allow you to do all of these things. So really, you really need to look at the big picture and to find the tools and the frameworks that can capture most of the needs that you have. Okay. So for us, this led to really thinking about the central data lake, because we have a lot of data and different types of data, and we want to have it centralized in one place, because anyway, we want to build the customer master that we will need for churn analytics, for the chatbot, for other things, etc. Right? So we really need a central data lake where we have everything. We need a unified analytics platform that allows us to do a lot of things like SQL querying, like machine learning, like real-time streaming, like segmentation, clustering, all of these things. So the analytics platform should be really versatile in this sense and able to do all these things and cater to all these use cases and data products and data flows. Also, the API layer is quite important, because you might be taking data from external system or ingesting them in new systems. You might be using some APIs like OpenAI API to, for instance, enable your internal or external customer-facing chatbots. So it's also important. And last but not least at all is data governance. So implementing strict data governance policies and tools, making sure that you're implementing the right retention, you're using the right type of storage, cold versus hot storage, etc., that you're implementing and enabling data anonymization when the customer leaves you, etc. Okay, so this is also very important. And for instance, for our use case, this is kind of an overview of our target data architecture. And as you can see, it involves things like event hubs and data factory for ingesting data. But then we aim to use Fabric because it has all these functionalities. We use mainly Azure. We're a bit tied to the Microsoft ecosystem, but it could apply to any other, provider or cloud provider. So here we use like one lake, and it allows for really ingesting a lot like many types of data. And we use also the Fabric Analytics Suite, because it also caters to all the use cases that we need. It has a default integration with Power BI, for instance. And I think what is nice about it is that it integrates really well with the Microsoft D365 ecosystem, which we use for our enterprise applications, like our CRM, for instance. So this means that a lot of the things that we produce here, like for instance, let's say the churn view, we can ingest into a customer service module in D365, etc. So that's basically what we decided to go for. But really, I'm not here to tell you should go with Microsoft or Azure or Fabric. It's really different for different companies. It's more why we did this choice and what has driven this choice. And here, this is just like a bit of the kind of data that we're using, the kind of analytics we're doing on top, and then the kind of the APIs that we're using. So I think that's it for me. I couldn't go further in terms of doing slides. It was quite a busy week in Gothenburg, but but I hope this was useful for you and useful framework for you. And yeah, let me know if you have any questions. Thank you.